Good afternoon, everyone. Now, this is like a topic rainwater leakage first and its attention that's what been given assigned to me. For many of you, it's been a repetitive section, I guess, because Sri Dinesh has already taken a detailed and long presentation, which even I am like wondering how he had got the time to make it and all. So I'm fine with it. I mean, since everyone is like more or less all of you are, guys are new, so you would be well versed with whatever Dinesh had already taught you. So it makes my life simple, I guess. Yeah, rainwater leakage testing. This is one area which actually, when it's summer, few of the sections will be actually happy. One reason to be happy in a summer thing for local studies is rainwater leakage. There will be less of a rain that's happening over here, but sooner we'll be able to see more any more booking if we are unlucky enough. Let's hope it's not the case as it comes forward. So why do we have to check for rainwater leakage? Simple reasons as it's pointed out, like equipment protection, preventing water ingress into sensitive electrical accessories or other electronic components like VCU converters. Like early it all were like a mechanical, electrical stuff. Now we are more into electronic stuffs and also it, almost all of them are case, but still there is a chance that water might percolate into it. So obviously it's our duty to avoid such cases. A lot of electronic components and like operational safety. Operational safety in the sense is local safety as well, eliminating electrical short circuits and grounding faults. Previously in conventional logos, we used to see like a many of failures were like a due to rainwater ingress, water coming into switch panel, relay panel. I think there is a case for 28609 that's presently available over here, in which I think it's HRIVT that's being melted. Chance is that it might be due to some rainwater leakage also that might have fallen into HRIVT. So there is a live example over here, which obviously someone will be testing it. Let's see how it is. So earth faults and like failures due to rainwater falling onto some LT or for that matter ST cables or like some switches or relay panels that might be misbehave and causing a failure. Operational safety. Crew ergonomics. Ergonomics in the sense for few of you who are new, you might not have seen that video where the driver was actually holding an umbrella and sitting and driving it. That is one of like worst case scenario for us to showcase for a rainwater leakage drawback. It's actually happened. It's been circulated over the internet. I mean, you can even view in some like a social media handles also. So obviously, any crew will not want rainwater to fall onto them for obvious reasons. Structural integrity, like I mean, outside and all we'll be painting about like the anti-corrosive like varnish types and also it's more or less protected, but inside like these components and some like dust where it's FRP sheets and all, obviously this rainwater might affect. So these are the basic reasons: safety, operational perspective, and for a comfortable working, for our peace of mind. These are the reasons why we are doing a rainwater leakage test. The shower test procedure. Actually, the procedure that's been detailed by Dinesh in his last PPT is like how it's being placed, where it's being placed, what will the PP will do, how the sections are going to approach, like what all the areas the sections might cover and all. So I just want to highlight an SMI 315. Actually, there has been many TC, like even TC4, TC 142, something that's been already mentioned about rainwater, but nowhere it's being specified or detailed as to how it should be tested, like what are the facilities that has to be there for the rainwater testing. Nothing has been specified before this SMI 315. And for that matter, this 315 is not related to how it should be tested, but it's like how the rainwater plant should be. That's what this 315 states. Uh, Probably many of you would have seen like a VSKP video where they are actually testing it. They have implemented over there. Hopefully, we will also try to implement it over there sooner or later. Maybe another couple of months. This plant might be installed over here I might need your suggestion also. Being in fabrication uh, section is being responsible for like installing it. So if at all any of you have suggestions as to how the rainwater leakage testing plan should be, please be free enough to communicate that to us. Obviously, while implementation or while like a commissioning it, it might be helpful. Obviously, there is this RDSO SMI in which there is a guidelines of how these nozzles should be, how these should be angled, how should be the length, what should be the length, like everything. It's been detailed over there. Apart from that, on a like a functional perspective, like on a practical sense, you people are the better judges who can actually give the input. Like this is like obviously to treat the leakage points in body points, mounting bases, all these procedures. Spraying water for roughly 30 minutes at 40 psi. That's what the SMA states. Now that amounts to like a rainfall of 44 centimeter per hour. That's how the SMA states 44 centimeter per hour. Like say even in like 10 centimeter per hour is almost a heavy rainfall to us. So 45 it will be seriously not a cloud burst. Cloud burst would be like 100 centimeter per hour, something like that. But it will be like a in between the stuff. It's a serious force that will be applied on the loco body, so we'll be able to test in a more realistic manner. I hope it says like about 30 minutes of continuous spray should be there. So obviously, the sump and everything should be that much big, like the whatever the underground reservoir should be that big. It's specified. If any of you want to have that 315 SMI, obviously Mr. Roy had made a board. You will be easily it will be easily accessible over this. Actionable items inspection is mandatory over spring 25. Yeah, it's obviously the testing 315 revision 0 TC 142. If anyone have to refer to, please be free to use Roy's board software. Critical leakage points. Everyone will be aware of this thing. Cab doors and windows, lookout glass, roof hatches, cable glands, wiper assemblies, roof equipment. Roof equipment, I guess many of you are here, especially auxiliary, E4B, wiper assemblies, our pneumatic section. They know what the seal should be, how it should be, what is the periodicity of replacing the seal, cable glands. Obviously, we see a lot of things in these new three-phase logos and all like a OHE sensors and everything, those fast lights that's being taken outside. It's taken through a entry point where that might also leak. Lookout glass, obviously fabrication section, cab doors and windows, obvious fabrication. Corrective action and maintenance. It's actually simple in the sense like every point of leakage is already known to us. But the problem for us is every logo is different, and like sometimes the scenario also changes. So gasket replacement is the first priority for like a lookout glass, cab windows, doors, everything. Sealant, lifeline of railways. I mean, in the sense of fabrication at least. Clearance of drain holes, roof bolt tightening for those who are in auxiliaries, painting and patching. If I were to say a gasket replacement, when you have to replace the gasket, replace any rubber seals that show signs of cracking, hardening, and permanent deformation. Deformation obviously will open up a hole or an area where water ingress is possible. Gasket hardening. A hardened gasket is a reason due to, I mean, is a reason that might result in like a breakage. Obviously, due to aging, heat, other chemical exposure, and all, a gasket could be hardened. Hardened gasket will have less flexibility. So, obviously, it will have more chances of opening up and might cut in near future. An application of sealant. Use industrial grade RCV, silicone sealants or polyurethane sealant around window frames and cable entries. There are two types of sealants. I hope you are aware. I guess anyone from Oxford who is aware of like what are the type of sealants? Dinesh, let's go. So plainly speaking, there are two types like what we use over here. That is one is polyurethane, another is the silicone. In polyurethane, that as it says, it as the name sounds also, it's like a some hi-fi stuff in the sense compared to silicone. It will give you better adhesion for like a metal parts and all. Will be able to like see for like a glazing type of like installation of glasses and all, obviously polyurethane thing is preferred. This will give you a fine precision of application and also a better adhesion. That's what is more needed. Silicone obviously can be used anywhere, but it's more flexible. It's more elastic. Where like the flexibility is needed, you go for silicone polymers, especially if it's like some elasticity, some sort of movement and everything. If it's like a rubber seal, if that might move like a vibrate or like shake during the movement, course of the movement, there and all like silicone polymers are the obvious choice. Apart from this, I mean this thing, polyurethane sealant is paintable. Silicone polymer should be used where it's already painted. Polyurethane might not deteriorate if you use paint. That's again a chemical stuff like paint. It's a composition of chemical. So wherever that needs to be repainted or like painted over, go for polyurethane. At least that's my suggestion. Or yeah, I might be wrong. If I'm wrong, you can correct me as well. Silicone is better where it is already painted. You need not repaint it. So both could be used depending upon the your purpose and like your precision, how it should be. Drain holes and all like it's routine stuff actually like roof channels. There should not be any blockage. If there is a blockage, water might try to percolate inside. Inside the we our erode modification is also there. Like we drain holes near the door so as water should percolate down, not enter into the gap. Roof bolt tightening. Obviously, if the roof is not tightened, if going at like 100 kmph to 160 kmph, due to the differential pressure, obviously the water droplets might enter and droplets might lead to like a stream. And painting and patching, obviously, if the body, if there is a small dent hole, obviously you can like a putty, metal paste, whatever it is, you can patch it up and like repaint it so that it might be avoided. Now, my point like that was stress was the rainwater leakage to liquid glass. So that's more into the fabrication stuff. So obviously, before applying a sealant, there are three steps actually. First is there is obviously beading you should provide. Beading, yeah, in the sense like even installation of glass, there is two ways by which you can install a glass. Like you have seen Amrit Bharat, even Vande Bharat, and you have seen our logos. So there are two types of like two different ways by which this glass is being installed. One is direct glazing. That's more like into the hi-fi glasses, the curved one. It's better that you go for direct glazing, that gives the proper adhesion. The another is that like conventional WP4 and WG9, what you see, like you use rubber beading. There will be two types of rubber beading. One is like what we say it's outer beading and inner beading. In the other perspective, it's like what are the glass holes, then will be a key beading that like acts as a stopper. For us, we say it's outer beading and inner beading. There is like a type of beadings that might be available over here. Whatever it is, before installing the glass, before like you're repasting or before you're putting the beading, you have to clean the surface. Cleaning the surface is a must. Surface preparation is a must. Because whatever you do, it's like added upon that. So you can use any ways by which you can clear the surface, like you can use an oscillating tool, a cordless one, you can use like a normal knife, but whatever it is, ensure that the surface is properly clean and there is no ups and downs so that it might not be like a mated properly while reapplying it. To ensure the surface is properly clean, a clean surface is mandatory. Use an approved solvent that does not damage the window material. Obvious, avoid harsh solvents using Lexan and polycarbonate glasses. Seal replacement, as I said, there will be like in lookout glass, what we see normally in like a conventional logos, there will be like two types of beadings, one outer and the inner. Upon that, we apply the sealant, that is resealing. If using a liquid sealant, example high quality industrial silicone or polyurethane sealant, apply it consistently to create a continuous watertight bead. Consistency is a must because you're applying like some sort of like here and there like a patchy work, it's going to leak some of the. I just put a video over here. So at least this is like a placing look out. I just want to show like how the beading would be. Nothing however, just want to highlight what the beading, how it would be like. Like the applying sealant using silicone, I mean applicator. That's what scenery highlights. Even like any offices that you have visited over prior, like a CLE, CE, everyone is insisting on like a don't use your hand to apply. It will not be consistent. Use a sealant applicator. This is a caulking gun that we call it. It's a sealant applicator in simple sense. You can use a codeless as well. That's available in the market, but not available here. Probably you might get in the near future. I hope so. But try to use the caulking gun as much as possible rather than using a hand. So this is how a sealant should be applied. So that's lookout loss, I guess. FL module, and it's not pertaining to me, but that's what I at least highlighted over here. FL, there will be like a roof equipment like VCB and everything, like what we install over there. The same thing. We will be using a beading. There will be like a, it should be properly welded and obviously properly tightened, and the glands should be properly covered. Thank you. Yeah.